Welcome back everyone, and today we are looking at semaphores in SystemVerilog. So during my previous videos in SystemVerilog process, I have discussed SystemVerilog events for synchronization, but events have a problem. It is that they don't have any sort of memory or storage, and compared to that, a semaphore is different. Think of semaphore as a bucket of keys. So you have to just use the inbuilt class. So semaphore is firstly an inbuilt class. So if you want to declare any instantiation of semaphore, you just have to write semaphore, and then you could just write whatever you want. So let's say our semaphore is A. So what will happen? You have just declared an handle or an instance of a class, which is an inbuilt class called semaphore, and it is a bucket of keys. And other process or agents in UVM will use those keys to access buses or to perform. So without any further delay, without any further confusion, let me demonstrate it with the help of an example. And like my every videos, I will declare a module called test. So the very first thing I'm going to do is to declare uh, a semaphore handle. So you just have to write the keyword or the inbuilt class semaphore, and then you could give any user defined name you want. Let's give it A. So after that, what I will do, I will run two initial block in parallel, and both of them will act as two processes running in parallel. And there I will show you the entire functionality of semaphores. So in semaphores, you have to use three types of methods that can be used to access the keys. So firstly, we have to declare the object of a semaphore class. So to do that, I will begin with my initial block. So in the very first initial block, what I will do, I will assign an object to A, and here is an important part. So inside the constructor, you have to pass a certain value in integer uh, to the handle. So that value decides that how many keys that particular semaphore will have. So by default, if you do not declare anything inside, or you do not write anything as an argument, semaphore will have zero keys. So zero keys by default, but for this examples, let's say we are declaring a semaphore called A with four keys. So we just did it. So we have just instantiated and assigned an object to a semaphore class, and it has four keys assigned to it. So depending upon the keys, the entire process could be blocked or could be executed. So I will write two process or two initial blocks in this case in parallel. Let's call our first initial block as process A, and let's begin with our another initial block. So here I will use three type of methods. So first I will just discuss those methods. So the very first methods that you will be using with a semaphore class is a get method, and get method is used to get the number of keys that you have assigned to the semaphore class. So here, suppose if we want to get certain number of keys, let's say 2 keys, we could just write the handle of that semaphore class, which is a in our case, and then using the dot notation, we will use the get method. Let's say if we want to get 2 keys, we could do that, and we could also get more number of keys. But in this case, since the total number of keys are 4, and if you try to take, let's say, 6 keys, what will happen? The entire process will get blocked at that statement. So the entire process will get blocked, and it will wait until the other process put the required number of keys by using the put method. So like get, which is used to retrieve the key from semaphore, you could also use put, which is literally the opposite, and it is used to put number of keys to the semaphore object. So again, you could declare any number you want. You could put 8 keys, you could put 10 keys, and it does not matter. So I have to clear one thing. Like here, you can see it right here that we have assigned 4 keys to this semaphore class, but it does not mean that this particular class is limited to only 4 keys. So later in any process, by using the put method, you could just put more number of keys inside that class. After all, it's just a bucket of keys, so you could put as many keys as you want. So that's the functionality of put method. And there is another method which is non-blocking in nature. So it's an alternative of get. So what will happen uh, here, that if you don't have the sufficient number of keys for this, for example, in this case, I have declared a semaphore with total number of 4 keys, and here I need 6 keys. So the entire statement will get blocked, and the process will stall until other process put the ample amount of keys. So there is another method which will check whether it has the total amount, the required amount of keys, and it will return true or false. So that is the try get method. So try get method is mostly used inside an if else conditional block. So what will happen here, let's say if I put 6 keys, if I required 6 keys, so it will just check whether the bucket or whether the object of that semaphore class has 6 number of keys. So if it does, it will just execute whatever statement you have written right here. For example, let us assume that we have a counter called count, so it will get incremented. And so if the semaphore bucket does have the required amount of keys, the if condition will return true and this particular statement will get executed. And if it does not, so unlike the get method, it will not block the process, and the process will continue on executing, and that following statements will be executed. So the try get method is non-blocking, and the get method is blocking. So without any further delay, since we have the knowledge and background of all 3 methods, let's begin with a very simple example. So here, let's say we have 2 process, and I am writing 2 initial blocks for each of them, and this one is process B, So in total, there are three initial blocks. The very first initial block is being used to assign the total number of keys to the semaphore handle. And then what we will do in process A, we will begin with some pattern. So let's say after a delay of maybe 6 time units, uh, we will just take two keys from the semaphore bucket using the get method. Then right after that, after 5 time units, we will again get one more key. And also I will declare a counter variable, and I will assign our default value of 0, and I will also monitor any changes to that variable using the monitor system task. And let's also declare at what time unit uh, at what time unit the counter gets incremented, or it has a change in value. So right after the second statement of the process A, after why I wrote this A should be 1. All right. So after right after getting one key, the value of the count will be incremented, and after that, 2 time units later, we will write an if condition in which we will use the try get method. And as I have already discussed, the try get method is non-blocking. So if the condition does not fulfill, the entire process will not get blocked, and it will continue executing whatever the next statements are. So it is try underscore get, and let's say we are trying to get two keys, and of course, since it's an if condition, we need to put some statement. So if this condition return true, we will increment our counter again. So that's all for process A. Now let's move on to process B. So here, let's say that at 7 time units, we are getting two keys. So remember, both the processes are running in parallel. So uh, there might be a case of race round condition, or both of them will be contesting for the keys from the semaphore A. So here, let's say we get two keys, and after that, let's say after 9 time units, let's put two key. So we are putting two keys. So this is the put method. As I have discussed, that get method is used to uh, get the number of keys from the semaphore object, and put method is used to put the number of keys. And there is in no way it is limited. You could put uh, as much keys as you want. So I am putting back two keys, and then let's say 3 time units later we just put 3 more keys. So I will do a brief walkthrough of every time slots and what is going to happen in both the process. So first, let's comment the exact time slots. So here, this will execute, of course, at 6 time units, and at 6 time units, after it takes 2 keys from our semaphore object, we have 2 keys remaining because it takes 2 keys, and 4 minus 2 is 2. So after that, what will happen? What is the time unit here? Right here, it's 5, which makes it occur at 11 time units. But before this will occur because it is happening uh, parallelly, and it happened earlier, and it is going to get 2 keys at 7 time units. So let us write 7. And since at 6 time units the process A already used the get method to have 2 keys, so here we are left with 2 keys, and right after that at the 7th time unit we are again taking 2 keys, but this time it is being done by the process B. So right after that we will have 2 keys, no, 0 keys. So we have 0 keys right here. And when does this happen? So you just have to add 9. The next statement happens in 16 time units. So of course, since it is happening in 16 time units, this will happen before this. But what will happen? So when we reach at the second statement at line number 17 of process A, it tries to get 1 key. But since at 7 time units process B already took the remaining keys, we are left with 0 keys. So what will happen? So as I have discussed right here, that the get method is blocking and the entire process will get stalled, and it will stop here at this statement, and it will not move forward until and unless the process B uses the put method to put additional keys so that it could continue on executing. So here it tries to get a single key at 11 time units, but since we are out on keys, it will get blocked, and it will wait till we reach 16 time units at process B. So at 16 time units at process B, we are using the put method to put 2 keys. So what will happen after putting 2 keys? The total number of keys will be 2. So right after when we put 16 at 2 keys at time unit 16, the blocked process, the statement in this block process will detect this, and it will just execute the get method since we have the ample amount of keys. So it will just wait till 16 time units, and then it will take 1 out of 2 keys, and then after that how many keys we will have? 1. So then we will have 1 keys. So right after that, as you can see, the count method is getting implemented. And just to recall it again, since get method is blocking in nature, it will wait for the other process to use put method to put sufficient amount of keys as required. So right after that, the count method will be incremented in the very same time slot, that is at time unit 16. So the value of the count will be 1, and this will be displayed by this monitor system task. So after that, what will happen? So this is occurring 2 time units after this particular statement, and this particular statement finishes executing at time unit 16. So this will happen at the time unit 18, and simultaneously we have a put method right here, which is happening 3 time units after this particular statement, and this particular statement happens at time unit 16. So this will happen at time unit 19. So the last statement of process A is occurring before the last statement of process B. So what we have right here? Here we are trying to use the try-get method. And as I have discussed earlier, try-get method is non-blocking. So it will check whether the semaphore object or bucket has ample amount of keys. So it is trying to get 2 keys, and as you could see it right here, after executing this particular get method, we were left with only a single key. So what will happen? Since it is non-blocking in nature, it will check, and when it will check, when it will see that there are insufficient amount of keys, it will return false, and hence the count will not get incremented, and the process will finish executing, and it will not get blocked in this line like it did in this line. So after that, process B at time unit 19 will put 3 keys, and till then this is of no use, because the process B has already finished, the process A has already finished executing, and this condition fails. So with uh, our deep code walkthrough done, let's go ahead and open the QuestaSim to run the simulation. Okay, I will compile the code to check for any errors. So, of course, our code got compiled successfully and we don't have any errors. So let's go ahead and start the simulation. Let's run the simulation. Okay, so you could see it right here that count is not getting incremented again right here. So if somehow we have reduced the delay at process B for the last statement, this condition would have passed and count would have been incremented further. So it starts with the initial value of both the arguments present inside the monitor system task, that is the value of count and $time. And right after that, as we have discussed the entire code walkthrough, the count gets incremented at this line, and when it does, the monitor system task detects it and it prints the value of count. And as I have discussed that it will happen at time unit 16 because it get blocked at time unit 11 because we were using the get method and there were zero keys during that time, and it is only during the time unit 16 by the process we put the ample amount of keys, and right after detecting the sufficient amount of keys, it executes this particular statement, that is the get method, at the very same time slot in which the process B put two keys. And right after that, in the same time slot, the count is getting incremented. So with our all the basics done, let's do a small fiddling. Uh, what I will do, I will just make it to put keys, uh, make it to put sufficient keys before this particular statement executes. So right now, the uh, it is putting three keys at 19 time units. So let's say we want it to put three keys, but we will reduce the delay. Let's say it puts three keys at 17 time units, since we are giving a delay of 1 and the last statement executed at 16 time units, this will execute at 17 time units, which is before this last statement of the process A. So with this modification done, this if condition should surely return true and the value of count will get incremented further. So let's go ahead and compile the code since we made some changes. Okay, and let's run the simulation. Okay, as you can see it right here that at at 16 time units the value of count is getting incremented further by 1. And as I have told you that this particular statement will execute at 18 time units. Sorry, it's 18. And it is because we are putting three keys back to the semaphore class earlier than this statement occurs, and it is being done by the process B. So let's just do a little bit more modification, and what happens uh, uh, if we are putting the keys at the same time slot in which the try get method is being checked. So we just have to give it a delay of 2 time units, which will change this to 18, and both the put method, which is by process B, and the get method, try get method, which is by process A, are being done in the very same time slot. So what will happen? Will we observe some weird kind of race round condition? So let's see. Okay, so even though the process B is putting the number of keys in the same time slot when the try get method is being encountered in the process A, it is still getting incremented. So yeah, so there is no ambiguity when we are not facing any race round condition. if even if we put the ample amount of keys in the same time slot, this particular condition or the try get method will return true. So this were the basics of semaphores. I hope you find this video useful. Please stay tuned for more. Thank you so much.